Good morning and good afternoon, everyone. This is the assignment for Introduction for Statistical Economy. We are the presenters by Grade 11. We choose Final Examination First Semester 2018/2019 Section Question 2 and Final Examination Second Semester 2018/2019 Section Question 1, Question 2, and Question 3 as our discussion topic.
I'm now solving question 2, Final Examination First Semester 2018 or 2019 session. Based on the question, we are given sample size equal to 400, sample mean equal to 25,000, population standard deviation equal to 2,500, confidence level equal to 95%. So we sub the numbers into the formula and then we get answer of 24,755 and 25,245. So based on the answer, we know that the average salary of graduates from the economic department will be around 24,755 ringgit Malaysia to 25,245 ringgit Malaysia. The confidence interval means we are 95% confidence that the true mean salary of all economics graduates lies between 24,755 ringgit Malaysia and 25,245 ringgit Malaysia. Based on the question 3, we are given x equal to 870, sample size equal to 1100, p equal to 0.7909, confidence level equal to 99%. And then we sub the numbers into the formula and then we get answer of 0.7592 and 0.8226. Based on the B1 question, we are given the sample mean equal to 3,375, sample standard deviation equal to 20, sample size equal to 50, and confidence level equal to 95%. And then we sub the numbers into the equation also, and then we get the numbers of 369.33 and 380.67. So the answer is the estimate true cost of the microwave is around 369 ringgit 33 cents to 380 ringgit 0.67 cents. Refer to the B2 question, we know that mean is 2 ringgit 98 cents, standard error is 0.1, and confidence level is 98%. So we sub the numbers into the formula also, and then we get 2.747 and 3.213. So refer to the numbers, we know that the estimate true cost of 1 kilogram of chicken is around 2 ringgit 75 cents to 3 ringgit 21 cents. Based on B3 question, we are given confidence level equal to 95%, desired margin of error equal to 0.02, p equal to 0.1. So for this question, we are going to find the sample size. So we rearrange the formula and we sub the numbers into the formula. And then we get 864.36. So 865 people must be interviewed.
Questions 1b. Here, 5% of the computer mouse produced are defective. We randomly select 6 units and want the probability that none are defective. Again, this is a binomial distribution. N equal to 6, P equal to 0.05, and we want P of x equal to 0. So P of x equal to 0 equal to 6C0 times 0.05 power of 0 times 0.95 power of 6 equal to 0.7351. So there is a 73.51% chance that all 6 mice are not defective. Questions 1a. We are taught that 60% of customers at Changlun Fried Chicken order a chicken burger, fries, and a drink. A sample of 15 customers is selected, and we want to find the probability that 10 or more ordered the full set. This is a binomial probability problem, where n equal to 15, p equal to 0.60, and we want p of x more than or equal to 10. So we calculate p of x more than or equal to 10 equal to p10 plus p11 plus until p15 using the binomial formula. After calculating and summing the values, the final answer is 0.4032. So there is a 40.32% chance that 10 or more customers order all 3 items. Questions 1c. A lecturer received an average of 5 WhatsApp messages per day. Assuming the message follow a Poisson distribution, what is the probability that she received exactly 2 messages? We use the Poisson formula. Here, lambda equal to 5, x equal to 2. So p of x equal to 2 equal to e power of negative 5 times 5 power of 2 divided by 2 factorial equal to 0.0842. That's an 8.42% chance of receiving exactly 2 messages. Question 1D. We are taught that the average family spends Rm 500 per month on food, with a standard deviation of Rm 75. What is the probability that a family spends less than Rm 410? This is a normal distribution problem. We first calculate the Z score. Z equal to, in bracket, 410 minus 500 divided by 75 equal to negative 1.2. From the standard normal table, P of Z less than negative 1.2 equal to 0.1151. So the probability is 11.51%. Question 1E. The mean income of middle management employees is Rm 37,200 with a standard deviation of Rm 800. We are asked, what range of incomes cover the middle 88%? According to the empirical rule, about 88% of the data lie within one standard deviation of the mean. So we calculate lower bound equal to 37,200 minus 800 equal to Rm 36,400. Upper bound 37,200 plus 800 equal to Rm 38,000. Thus, 68% of incomes lie within Rm 36,400 and Rm 38,000. Questions 1Fi. We are given mean equal to $3.1, population standard deviation equal to $0.2, sample size equal to 16. We are asked, what is the standard error of the mean? We use the formula standard error equal to sigma divided by square root n equal to 0.2 divided by square root 16 equal to 0.05. So the standard error is 0.05. Questions 1F2. Now we are asked, what is the probability that the sample mean is between $2.98 and $3.12? We compute two Z scores. Z1 equal to, in bracket, 2.98 minus 3.10 divided by 0.05 equal to negative 2.4. Z2 equal to, in bracket, 3.12 minus 3.10 divided by 0.05 equal to 0.4. From the Z table, P of Z less than negative 2.4 equal to 0.0082. P of Z less than 0.4 equal to 0.6554. So the probability between the two is 0.6554 minus 0.0082 equal to 0.647 or 64.32%. Questions 1F3. What is the likelihood that the sample mean is greater than $3.08? Calculate the Z score. Z equal to, in bracket, 3.08 minus 3.1 divided by 0.05 equal to negative 0.4. Then P of Z more than negative 0.4 equal to 1 minus P of Z less than negative 0.4 equal to 1 minus 0.3446 equal to 0.6554. So there is a 65.54% chance that the sample mean is above $3.08.
Question 2.1. What is the estimate population for divided curve in the population? P equals to x divided n. So x equals to 15 and n equals to 300. So estimate population for divided curve is 15 divided 300. So we get 0.05. So in conclusion, the estimate population for divided curve is 0.05 or 5%. Question 2A2. Develop a 95% confidence interval for the population for divided curve. So P is the sample population, which is 0.05, and N is the sample size, which is 300, and Z is the standardized normal distribution, which is 1.96. So now we calculate the confidence interval, which is 0.05 plus minus 1.96 times square root 0.05 bracket 1 minus 0.05 divided 300. So we get the confidence interval is 0.05 plus minus 0.0246 equals to bracket 0.0254, 0.0746. So in conclusion, the 95% confidence interval for the population for divided curve is approximately bracket 0.0254, 0.0746. Question 2A3. John Deere has an agreement with her supplier that she is to return lots that are 10% or more defective. Should she return this lot? Explain your decision. She will return the lots that are 10% or more defective. This is because from the confidence interval in 1, we know that we are 95% for confident that the true population is between 2.54% and 7.46%, which is below the 10% threshold. Since 10% is outside the upper bound for the 95% confidence interval, there is no statistical evidence that the loss is 10% or more defective. 2. No, Sarina should not return the lots. This is because the evidence suggests the defect range is significantly below 10%. 2B1. Find the point estimate for means from the data above. Sample means formula, which is for all sample means divided total number for sample. So we need to plus all the number in above and divided 15. So we get 1342 divided 15. So we get at 9.467. In conclusion, the point estimate for the means is at 9.467. Question 2B2. Construct a 95% confidence interval for the population mean. So now we want to find the deviation. So the formula is the sum for bracket each value from the sample minus the sample mean. So for value 94, we want to find the deviation. So we need to use bracket 94 minus 89.467. We get 4.533, and we want to find the square deviation. We use bracket 94 minus 89.467 to the power of 2. So we get 20.55. So each number in the table, we need to calculate the deviation and the square deviation from 94 until 84. Step 1. Sum for square deviation equals to 913.72. S power of 2 equals to 913.72 divided 14 is approximately 65.267. So S is equals to square root of 65.267. We get 8.08. So step 2, find the critical value. T equals to 0.025. So degree for freedom equals to number for sample minus 1. We get the 14. From the T distribution table, T equals to 0.025. And we want to see the horizontal line 14 is approximately 2.145. So step 3 is calculate the standard error. Calculate the standard error formula is S divided square root of n equals to 8.08 divided square root of 15 is approximately 2.09. So step 4 is construct confidence interval. Mean plus minus t distribution times standard error equals to 9.467 plus minus 2.145 times 2.09. Margin for error is approximately 4.46. Confidence interval is at 9.467 plus 4.46, we get 93.93. And at 9.467 minus 4.46, we get at 5.01. So in the conclusion, the 95% confidence interval for the mean expenditure is approximately bracket 93.93 and at 5.01. Question 2B3. Is it reasonable to conclude that the economy students have a mean expenditure in the ordinary level? The entire confidence interval bracket 93.93 at 5.01 is above 80. So we know that reasonable conclude that the true means expenditure is above 80, indicating students are spending at the ordinary level. It is reasonable to conclude that the economy students have a means expenditure in the ordinary level because the entire confidence interval is above 80.
List the 5 steps to perform hypothesis testing. Step 1. State null and alternative hypothesis. Step 2. Select a level of significance. Step 3. Identify the test statistic. Step 4. Formulate a decisions rule. And Step 5. Take a sample. Arrive at decisions. Do not reject null hypothesis or reject null hypothesis and accept alternative hypothesis. What is hypothesis testing? Hypothesis testing is a procedure based on sample evidence and probability theory to determine whether the hypothesis is a reasonable statement. What is the p-value? A p-value or probability value is a number describing the likelihood of obtaining the object's data under the null hypothesis of a statistical test. The p-value serves as an alternative to rejection point to provide a smaller level of significance at which the null hypothesis would be rejected. A smaller p-value means stronger evidence in favor of the alternative hypothesis. So based on these questions, we are given sample size n equal to 400, number of defective apple equal to 50, so sample proportions p equal to 50 divided by 400, so equal to 0.125. Population proportions equal to 0.1 and significant level equal to 0.025. First, we set out the hypothesis. Null hypothesis p less than or equal to 0.1 and alternative hypothesis p more than 0.1 because the claim is more than 10%. Next, we set up the Z formula to calculate, and we get the answer Z equal to 1.67. We found the critical value. Since alpha equal to 0.025 for a one-tail test, the critical Z value is 1.96. And last, we want to make the decisions. Our compute Z equal to 1.67 less than 1.96, so we found to reject the null hypothesis. In conclusions, there is not sufficient evidence to support the claim that more than 10% of the apples are defective. For questions D, to solve these questions, first we set up the hypothesis. Null hypothesis means more than or equal to 6, and alternative hypothesis means less than 6. And next, we compute the mean. 45.1 divided by 8, we get the answer mean equal to 5.6375. And we compute the standard deviations. We get the answer sample standard deviations equal to 0.6346. Next, compute the test statistic, and we get the answer negative 1.615. We determine the critical value. Degree of freedom equal to 7, and at alpha equal to 0.01, so the critical value is negative 2.998. Last, we make the decisions. Compute T equal to negative 1.615 more than negative 2.998, so we failed to reject the null hypothesis. So, in conclusion, that there is no sufficient evidence at the 0.01 significance level to conclude that the mean rate of return is less than 6%.